Hi everyone, Paul here from Davra, and in this video we're going to take a look at Unit 8, Test Automation. In this unit we will talk about best practice for test automation of IoT applications deployed on the Davra platform. So before we get into the test automation part, we first need to set up a microservice on our tenants so we can host the application and then set up the application itself. So the first thing we need to do is create a microservice via the Davra API. And when creating this microservice, we need to set the value of template to Docker. This type of microservice allows us to edit our code independently, build our own Docker images, and use our own private Docker registry. And you can read more about that feature in our documentation, but we'll go into more detail later on in the video. Okay, so let's create this microservice. Template, as we said, we need to set it to Docker, and name, we'll just go Unit 8, and let's create this. Perfect. Now, moving on to the next part, we need to go to our tenant, navigate to the services page, click on the microservice we just created, and in the red section, click the Add button and select Davra name virtual host, which will create a vanity URL for us. Okay, so we're on our tenant now, and if I go to the services page, click Unit 8, which is the service we just created. And we can see now we will add Davra name virtual host, which will create a vanity URL for us. Okay, let's move on to the next part. So we need to create an OAuth client, as our front-end application will have an OAuth integration. To do that, we need to go to the OAuth clients page, and when we click the Add button, give it a name, and in the callback URL text field, paste in the vanity URL we just created and append /callback to it. Okay, so let's do that. So like I said, we need to take note of this. Okay, if I move myself out of the way for a second, I can click Add. So callback URL, and then I'll put callback at the end of that, and then we'll go Unit 8 client, and we'll create that. Cool. And then also it says if you wish you can edit the login and authorization style of your client. So let's quickly do that. I have some stuff saved that I want to do. Davra logo. And then image. Background image. There we go. Sorry. And let's save this. And let's move on. Okay. Okay, IoT application. So you can start by forking the following repo, which is here. This is just a very basic template. It's a Vue app using Vuex and Vuetify. Okay, and from here we look at the README file and follow instructions for adding the necessary environment variables for both production and local production. Okay. This is just the layout of the repo for environment variables. What we need to do is create an env file in the root and add these. And we can look at env.example to assist us. So if I open up, I've already cloned the repo. So if I here, and this is a new file. It's going to be .env. Okay. And my tenant is Paul mcn.davra.com. My target host, that is, so it'll be this URL here, and you can leave out the HTTPS. Now client ID and client secret, that you can find here in your OAuth client. And the secret as well. Cool. So that is that, and we should put these as strings. Perfect. Okay, so the next part is in the client directory, we create another env file. So let's do that. Client, new file, dot env, and there is another example to help us. So your tenant host, which as we know is Paul MCN. Local development, true if you are, but in this video I'm not. If you wish to do some adjustments, you just set this to true, and you'd also get a view app token from your user, and I'll show you how to do that in a second. Our microservice name, as we know, was just unit 8. And we need a Davra admin login, so to do that, we'll just create a user. Okay, we'll just go unit 8 user, and we'll just go do an easy to remember password. We'll just and I'll delete this user after this video, and we'll give him an admin role. And we see that user has now been created. And to generate the API token, you just do that. You can copy it and paste it in. And as I said, you need that for local development if you are doing any. So our login was unit 8 user. And the password was hello 123 dash. Okay. And yep, now that's all the environment variables for the Vue app we need to set up, I believe. So if we go back to our template, you can see, and for this is for local development, for compiling and hot reload, cd the client folder, npm run serve, and then to test the server, you create the env file, which you've already done, and run sh start sh. So now this is going back to the Docker servers, where I said we look at in more detail later on in the video. So in order for our microservice manager to pull the image from your external private Docker registry, you need to authenticate it. And in our help documentation, there is several examples how to do that with different registries. So for this video, we are focusing on AWS ECR, but there's also examples for doing it with Docker Hub and also Azure Container Registry. So for doing this, we're not going to follow this entire tutorial. We only need to go as far as this part, which is where we're creating a Davra secret. The rest of this tutorial, the Jenkins pipeline we will set up and run at the end of the video, will take care of this bit for us. Okay, so let's get into creating or authenticating with AWS ECR. Okay, so a few of the things you need to follow. You need the latest version of AWS command line interface, and you need your AWS credentials, which is your access key and security access key. You can find how to get them in the help documentation for AWS. Okay, so let's log in. Now your region might be different to what I'm putting mine as. Let's see. Cool. We have a token. This token, you have to use it within a few hours, I believe, or else it will expire. Okay. Next, we are going to encode this in base 64. So what we do there is so echo AWS is the username in this case. AWS, and then it's the big long token, so this here, and then we want it in base 64. Cool. Okay, so we have that. Make sure when you're doing this you're getting the right stuff and that. Okay, next let's just, so we need to create a docker auth JSON file. Let's do that. We'll just do it in this repo for the purposes of this video, and I'll delete it before I commit my code. Okay, and this is the string we need. Let me move this down so you can see. And then get the A64. Okay. Perfect. And then, my region, as I said, is US East 1. And then you can, what you do is your AWS account, this is your account ID, which you can find in your container registry UI on AWS. And what you do then is you just add that here. So I will do that now. Let me just pause. Okay, so I've added my AWS account ID, and if we go back to the documentation, we can see what to do next. So now we need to encode our JSON file in base 64. Okay. So let's do that. Perfect. So now we have our auth file in JSON. The next thing we need to do is create a secret, our Davra secret via the API. So if I go to Postman, the endpoint is just your tenant / API / v1 / secrets. Okay. So we'll go Unit 8 AWS creds. Oh. And then we add our base 64 encoded file. Perfect. And now we'll just create that secret. Perfect, okay. See it's created. Make a note of the UUID. You'll need that for later, or you can just make a GET request either. Okay. So if we go back to our README. Okay. So now we are ready to move on to the next section, which is our Jenkins pipeline. So in the root of your Git repo, you'll see a Jenkins file, which is a scripted pipeline that will do a number of things, including build your Vue app for production, build the Docker image, push it to Amazon ECR, run a container scan, and then finally update your microservice config so we can pull in the new image and run the updated app. Now the container scan, so this is a basic scanning type provided by Amazon ECR to check for common vulnerabilities and exposures, and as long as there are no critical or high vulnerabilities detected, the Jenkins pipeline can move on. If not, it will fail. If you just take a look at the code, and I can show you exactly what I mean. So this is where it starts the image scan, waits for it to complete, and once it's finished, here we are checking, okay, assert that there is no critical or high vulnerabilities. So that's just one cool feature. Oh. Okay, so to get started with our Jenkins pipeline, we can see the setup again in the GitHub file in the README. So let's take a look. Now there are a few prerequisites. So you need to have obviously Jenkins instance, and then you need to have Docker installed on the Jenkins instance, any plugins. You need to have a repo already created in AWS ECR, or if you're going with Azure, CR, or something else, then you can modify it and work that out yourself. The latest version of AWS CLI v2 installed in Jenkins instance, and then your GitHub credentials added to the Jenkins instance as well, so it can clone the repo, or if you might not need it if it's a public repo or not, but if it's private, you will need credentials. Okay, so let's first of all, we're going to add two sets of credentials. We're going to add our AWS credentials and our Davra tenant admin user credentials. Okay, let's go ahead and open up my Jenkins instance. So to add credentials, go to credentials, some global credentials. Now I already have my AWS credentials added, so but to follow the pattern, you can just mirror the same pattern for when I'm adding my Davra credentials. So we're going to call it, the ID is sample app credentials. And our username, as you recall, it was unit 8 user. And the password was hello123 dash. Cool. Let's just create that. Perfect, so that's here. And then you can follow the same pattern for creating your AWS credentials. But in the username field, put the access key and the secret key. And you can look at the AWS documentation for how to retrieve those for your user. Okay, now let's create the pipeline. So go back to our home page, hit new item. You can call it whatever, so I'll call it sample. Actually, we'll call it unit 8 pipeline. We'll stick with the same naming convention. Pipeline, select pipeline, and okay. Now we need to check this, so this project will be parameterized, and that box is here, and I believe we have a total of 7 parameters. So your tenant ID, so, and these are all going to be string parameters. So actually, let's just copy and paste this. So you have your tenant ID. You can put in the default value of your own tenant if you only have one tenant. I don't know, it depends. So for me, that's Paul MCN. Okay, we'll just trim the string. Another one, I believe it's host. It's the next one, yes. So, and that is, again, you go to your services page, and it would be the URL that's in the red section, the vanity URL. So this here, copy link, go to the address. So if we go back, and you can drop the HTTPS. Next, service. So that's the UUID of your service. And you can get that either via the API, or if you go to the actual service in the UI. If I bring this down, you can see in the URL the UUID is there. So let's just copy that. Okay, and we'll add that. Okay, next, I believe it's secret. So this is the UUID of the secret that you created earlier in this video. So that's here. I just need to grab it. Okay, and now trim that. Next, this is your AWS account ID. You would still have this from when you created the secret. If you recall, you needed it for then. And you just put that in there. Let's go 124. That's the default. Next, we need registry name. So this is the name of your registry in AWS ECR. Okay. For me, I'm just going to go Paul test. Next, the region that your ECR is in. And for me, as you might recall, it was US East 1. Okay, so that's all our parameters, all 7. Then next, we're going to select in the pipeline definition, check out from source code management. If you are proficient, are competent enough to write the pipeline script, you can just copy and paste the Jenkins file, and you just have to add the bit about checking out the source code. Okay, but first we'll just use this. Git. Now your repository URL, so don't paste in the template one. So when you fork this repo, you'll have your own URL. That's what you'll use for this. So that's exactly what I'm going to do. I have my own. And I'll paste it in there. And then select your GitHub credentials. You might use SSH token instead. Up to you. Branch. Whatever branch you want. Just go main. That's mine. And then Jenkins file. And that's it. So we hit save. If we go to tutorial, there's no other steps that we have missed, have we? I don't believe so. No, we do not. Have not. Okay. Perfect. So if we go to build with parameters, you add in any parameters if the default ones you have are incorrect. And then do not click build yet, because as I said, in this pipeline, if I pull it up here, at the end of the pipeline, so first, as I said, the pipeline, it builds your Vue app, it builds a Docker image, then it pushes it to your ECR registry, does the container scan, updates your Davra microservice config, then it waits for the microservice manager to pull in the new image and get that up and running. And then finally, what it will do is it will run the playwright and Tenable jobs in parallel. And it's important, so you may need to change whatever the name of your playwright and Tenable jobs in to put that in here. And there may be parameters you need to add. So if I go back, for example, this job that I call is called Unit 8 Pipeline. So if I wanted to run, if your playwright job is called Unit 8 Pipeline, that's what you put in here. Okay. So in the next part of this video, you are going to see how to set up your playwright and Tenable jobs. And then once that's done and you have that set up, then you can hit build and watch your pipeline build, deploy the image, run the tests, and see the results. Okay, and so again, I was reiterate, it's important that you have these names identical to whatever your playwright and tenable jobs are. Okay, so that concludes the first part of this video for getting your IoT application ready for deployment and setting up your Jenkins pipeline. So now we will move on to the playwright and tenable sections of this video.
Hi, in this video we're going to set up a test automation project for the sample app you've just deployed. Internally at Davra we use Playwright for UI and API testing and Lighthouse for UI performance audits. In case you're not familiar with Playwright, I highly recommend you start with their official documentation, which covers the basics of how this can be used for testing in general. In this video we're not gonna cover the basics, we're gonna focus on how it can be used specifically to test applications built on the Davra platform. So if you haven't used it before, pause here and go over the basics of their getting started page and maybe the first few bits of the Playwright test section. This will give you enough background to follow with the rest of the video. And if you've previously worked with tools like Selenium or Cypress, you'll probably find that a lot of the concepts are quite similar. Now, in our project, we're going to go into some more advanced features of Playwright, such as fixtures or visual comparisons. So go ahead and read up about them now if you want. Otherwise, you can go back to them after having a look at their practical applications in our sample project. Okay, so with the Playwright introduction out of the way, let's have a look at the actual template we're going to use for our project. Follow the link to the GitHub repository here, and you'll notice it's configured to be a template, meaning you can use it to start your own project and keep the exact same file structure. So go ahead and use this template to create your own repository, and from there we're going to go over the initial setup required to get your tests running. Once you have your own copy of this repository, the first thing to do is to install dependencies. So open a new terminal in the root directory of your project and run npx playwright install deps. Confirm. Right, once that's done, you'll have to install all the other dependencies with npm install. Next, we're going to set up the environment variables needed to point your tests at the sample application you're running. Take a look at the README included in this project. You'll see there's a setting up environment variables section which outlines exactly what needs to be set. I already set those up in my terminal and I skipped authentication method because I'm using the default one. Okay, once you have your variables set, you're ready to run your tests to confirm everything is configured correctly. So do that with npm test. This can take a while, so I'm going to skip till the end. And there we go, after about a minute, all our tests are passing. So with all the setup out of the way, let's look at what's actually included in this template. First, let's take a look at the tests folder. So in here, you will find all the sample tests created for the dummy application. Their only purpose really is for you to see a practical example of how certain scenarios can be handled. We won't go into any of those in particular detail, but let's just note that every spec file has a title that explains what area it covers, and inside each spec you will find a brief description, possibly some links to relevant documentation on Playwright's website. Now, apart from the tests folder, let's have a look at the pages folder here. Now, if you have previously worked with any UI automation tools, you are probably familiar with the concept of page objects. This is an example implementation of page objects with Playwright. In the long run, when you develop your application, you will most likely want to delete most of these, keeping only the index and base. But when you build your own page objects, you can use whatever's already here as a sort of guideline. One thing to note about page objects in Playwright as opposed to tools like Selenium is you'll notice they tend to be quite lean, and most of their contents are just locators or functions that return a locator. And that's because in most cases, Playwright can handle interactions with elements without having to use complex methods. Okay, now let's look at the global setup. When looking at the tests, you might notice that they don't actually do any authentication. All of them, or pretty much all of them, skip the logging part altogether. And instead, they rely on global setup creating an authenticated state that every page created afterwards can reuse. Now, to give some context on what global setup actually is, this is a function that will execute once before any tests run. And within this function, a browser will be opened, it will go through the login process once, and if successful, it will save the authentication state. Afterwards, by default, your tests will use that state. If you ever find yourself in need of running a test where you are not an authenticated user, take a look at the example tests, and we have that scenario covered there. Next feature worth mentioning are the API utilities. So when running your tests, you will quite often find yourself in a scenario where you need to interact with the platform, and you might not have a way or desire to do it using the UI. And that's where the API utilities shine. For example, let's say you have a scenario where you need to test a feature that requires a device to exist on the platform. You can use your API utilities to create a device before the test and delete it after the test. And the test itself doesn't have to concern itself with any interactions with the platform. It just goes through your app and it knows the device is there. And apart from devices, API utilities will make interactions far easier with digital twins, rules, twin types, and handling data, so data uploads and deleting any test data you might have created. If you want to see an example of how those are applied, go to your tests folder and we have an API utilities spec that shows some examples. And last but not least, let's have a look at fixtures. If you haven't worked with fixtures before, they can be a slightly confusing concept, but everything in this project relies on them quite heavily. They can be used to create test data for your test or instantiate page objects and many other things. And as you develop your project, you will likely end up with a lot of custom fixtures that will just make your life significantly easier. I suppose a not so complicated explanation of how fixtures work would be by example. So let's look at the test device fixture we have in this project. Every fixture you'll see has one section before the test, and it might have one that happens after. So in this example, we create a device which we then pass to the test. Now, the steps after this line won't execute until the test has finished, meaning this is essentially the setup for the test, and this is the cleanup. So if we pass the test device fixture to any of our tests, what's going to happen is it's going to create a new device before running the test. It will run the test, passing the device object to the test. so it can access its properties like the UUID or name or whatever it needs. And afterwards it's going to delete the device. So we don't have to explicitly define that in the test itself. Just passing it the fixture handles all the setup and cleanup. And the important thing to note, you can use as many fixtures as you want in a single test. So for example, if you needed to have a test device and a test twin, you just need to create a fixture that will provide you with a twin, and you can call both of them in your test. Now, as I mentioned, if you haven't worked with fixtures before, this can be a lot to take in. So definitely take a look at the existing fixtures in this project, as well as Playwright's documentation about how fixtures work. It's quite comprehensive. It explains what's there by default. So the default fixture for handling pages and browser contexts. So this entire page is worth getting very familiar with, considering a good understanding of these concepts will allow you to write very clear, modular, and nicely isolated tests. And if you have them nicely isolated, it makes it significantly easier to run your entire test suite in parallel. So that's it for the key features of this template. One more thing that's worth mentioning is the general configuration. You will see that the template has a playwright.config.ts file, which contains project-wide configurations. So, for example, timeouts that would apply to all the tests or all the assertions. You can set up cross-browser testing by adding different browsers to the list. You can configure your reporters, the number of tests running in parallel, and much, much more. So this initial setup might work for you. If you need to change anything, there are 2 full pages of information on Playwright's website. One configuration for most commonly used features, and if you have more complex needs in this area, the article on advanced configuration should have what you need. The README for this project also includes some more in-depth information about some of the things we talked about, plus more that we haven't really touched on here. So you will find sections on things like visual testing specifically, or more information about page objects, fixtures, and such, as well as a step-by-step guide on how to set up your tests with CI. Now, after you've gotten familiar enough with the included tests and page objects, and you feel confident that you can apply the same concepts in your tests, you can remove everything from this repository that exists there specifically to test the sample application, so that you can use it as a clean sheet for your own automation project. So the parts you can safely remove are all the tests in the tests folder. Whatever tests you create yourselves, if you put them in the test folder and they end with .spec.ts, they will be executed as part of your suite. As far as page objects go, you might want to keep base and index just so that the general method of instantiating page objects is preserved. Ditch everything else, and in index.ts remove everything that's marked as to be deleted. So all the imports and getters for page objects that have been removed. And once you wipe your page objects and tests, the last thing to remove to really make your project blank are the fixtures that are used to instantiate page objects in our tests. They are all marked as to be deleted. So find them all in the fixtures file, remove them, and remove them from the interface. And that's it. Now, this will be a great starting point for any tests you wish to write for your application. But as I mentioned before you remove all the fixtures, tests, and page objects for the sample app, make sure you really understand all the concepts that were applied there, so you can use them in your own tests and not have to reinvent the wheel. Okay, that's it for the playwright part. Thanks and good luck.
Hello, my name is Jude. I'm Senior QA Engineer at Davra, and welcome to the final section of the Davra Dev Portal Getting Started Unit 8, Test Automation. And this section covers security scanning. Just to let you know off the top, to follow the steps in this tutorial, you will need to have access to Tenable.io Web Application Scanner, WAS for short. So why do we need security scans? Well, we need to understand the risks in our web applications, and Tenable software analyzes and reports any risks for us with its web application software. We also need to keep up to date with the OWASP Top 10 Vulnerabilities. OWASP stands for Open Web Application Security Project, which is a de facto industry standard for identifying and keeping up to date with security risks, which are constantly evolving. So here we have our Tenable security scan template on GitHub, and this has all the required files for setting up your own Tenable security scan inside Jenkins pipeline, or even running locally if you prefer. Inside this repo, we have our Jenkins file, which we use for the pipeline. We get into that later on. We have the README, which contains all the low-level information for setting up your own security scan. And then we have this Tenable-web-app-security-scan.js script file, which we'll have a look inside this. This is where we can configure how we want our scan to run. Okay, so the first part to look at in this script is at the top here. This is where we can configure the level of vulnerability, severity, warnings we want our Jenkins pipeline to fail at. So here we have critical, scan level critical, first one, scan level critical plus high, scan level critical plus high plus medium, and then scan level critical plus high plus medium plus low. So based on your selection, this will determine how Jenkins reads the report from Tenable and if Jenkins will succeed or fail. Quick look here at the Tenable generated Tenable report on the Tenable dashboard. As you can see here, it's broke down with a critical vulnerabilities, high vulnerabilities, medium, low, as our script, as per our script. And this particular report, we have some medium severity warnings and low severity warnings. So back to our script here. The default setting for our script for scan level is critical plus high. So suppose if we were to run this script with this configuration against the Tenable scan, the report we just were looking at, this would succeed, as we are not looking for medium or low level vulnerabilities with this configuration. So I suppose we will, if we were to change the script to look for low, medium, high, and critical, then we would expect our Jenkins pipeline to return a fail. So let's give that a try. So here we have our Jenkins pipeline. We can just go through this quickly in the configure section. Let's scroll down here. So the quick setup, a quick rundown of the setup here in the pipeline. We're using definition pipeline script from SCM, source code management. For that, we're using Git, as we seen before. We have our repository URL, our credentials, which are set in Jenkins managed credentials, and our branch, which is branch specifier, which we're currently pointing at main. Then down here in the script path field, we're pointing at our Jenkins file. This should point to the path of the Jenkins file, but we have our Jenkins file in the root of the repository. So that's it, basically. So we return back here, and now we're going to run this build. Let's have a look again in our script file. Yep, we're set to critical plus high plus medium plus low. So we run this build now. We expect this to fail. So let's click this. This will take a few minutes to run. So we'll come back when it's completed. So while this scan is running, it's worth mentioning if you'd like to run this scan locally, there's one part on the security scan template script file that you will need to fill in, and that's on the this line here with the LED API keys. You need to get your Tenable access key and Tenable secret key. These are generated by Tenable, and you can look at your Tenable documentation to find out how to get these, and then just fill them in on this line here where the question marks are, and then you can run this script locally following the steps in the README. So yeah, as you can see, 9 minutes 27 seconds later, as expected, our Jenkins pipeline has failed. It's worth mentioning here that it's not Tenable that decides whether its scan report passes or fails, but we are setting the assertion through our security scan script to say what levels of vulnerability we want want the scan, or we want the Jenkins job to pass or fail at. So in this case, it is failing because we can go look inside the output. Yeah. In this case, we have a result fail because it's found 7 severity vulnerabilities at levels specified: critical, high, medium, low. So that's why this scan is failing. We are making that assertion and not Tenable. And just to clarify that, here's the output from the Tenable report. We have our 7 low and medium severity vulnerabilities that Jenkins has asserted against. Okay, so let's go back to our script, and this time we want the Jenkins build to pass. So what we will do, go back to the editor. We'll comment out our critical, high, medium, low, and we're going to comment in our critical and high. So we know this report does not generate any critical or high vulnerability, so we expect our next Jenkins job to pass after we save this, of course. Okay, so we go back to our Jenkins pipeline and we hit build now. This will take a few minutes again, so we let that run. Yeah, one other thing we should mention is these scans have been run against our sample IoT app, which I'm sure you've encountered already from earlier on in this unit. So yeah, 8 minutes 27 seconds later, our Jenkins build is complete, and as expected, this time we have a success. Yeah, I mean, the Tenable scan is probably identical to the one from our failed job, but it's our Tenable security scan template script, which is setting the criteria for whether this build should pass or fail. And this time we have a pass. We'll go in and look at the output quickly. Whoops again, and go down the bottom, and we have no severity vulnerabilities at level specified: critical plus high. So quick mention on reports. Well, our Jenkins build does generate an exported report from Tenable in JSON format, as you can see here in successful artifacts. But this is very tricky to decipher. We would like to have HTML reports here, but Jenkins has a content security policy which won't let us display them, and we don't want to override that, as we don't know what the consequences might be. So the best way, I think, to view the reports is inside this, the Tenable dashboard. So here in the dashboard on the report page, we can select the export button up here, and this will give us the option to export as HTML, PDF, NSS, CSV, or JSON. Recommend HTML, PDF if you want a nice display and easy to consume reports. So we can select HTML, export, just see an example what it looks like. This might take a few seconds. Okay, so we open up our web application exported HTML file from Tenable, and here you can see a nice breakdown of the report and what is contained inside the report. So a few other things to mention. We can have a quick look inside the Jenkins file to see what's configured in there, so our Jenkins pipeline can run. So we just have this section here. We are setting up our credentials. These are the access key, secret key that we get from Tenable. We have these stored inside our Jenkins managed credentials. They're picked up from there. And then basically the scan config name, and we have some alerting and a timeout there as well. And then finally down at the end we have we're asking to archive the reports. Those are the exported JSON files that we have in the Jenkins pipeline. Okay, so that concludes this tutorial on security scanning. I hope it's helpful to you and you'll have some success with it. Goodbye.
Okay, now that you've set up a pipeline to run your Playwright test and your Tenable security scan, we can now run the first pipeline that we set up at the start of this video. And if I just remind you, so if I go to my dashboard, see I have Playwright job and Tenable job, and here's the original one that I set up earlier. If you go to build parameters, now just to remind you what exactly is happening in this pipeline. So we're cloning the repository, so this will be your repository that you forked from the sample IoT template. Installing the dependency for the view application, building the view application, then you're building your Docker image, pushing it to your AWS ECR, then running the container scan, all going well, there's no critical or high vulnerabilities, we're moving on. Updating your microservice configuration with the new image and tag. You can see that here, this is the Docker image, so this is your ECR with the registry and then the image tag. And for this video, our image tag is always going to be the Jenkins build number. And then the secret, this is the secret you created earlier with your credentials to log into, so our microservice manager can log into your AWS ECR. And then here we're just waiting for the service to update with the new image and run it. And then finally at the end we're triggering the Playwright and Tenable jobs to run in parallel. And as I said earlier, please ensure that this Playwright job and Tenable job match what you called your jobs. For me, it is Playwright job and Tenable job, so I don't have to change anything. And then we're just passing for Playwright job, we pass in a branch parameter, and it's just going to be main. Okay. Now, so let's build with parameter, or wrong one, sorry. Unit 8, we're going to build parameters. So, as I said, the host, that's your tenant ID. Host is the vanity URL you created. Please also make sure that when you're pasting in the URL that you leave out sometimes when you copy it will have a slash at the end. Please don't leave that there, get rid of it because it might mess up. The UUID of your microservice, the UUID of the secret you created, your AWS account ID, the name of your container registry, and then the region that it's in. Okay, so I'm just going to enter my AWS account and I'll click build then. Okay, so our Unit 8 pipeline is now running, so it's going to run through the steps. Currently it's on the stages. Currently it's on stage 3, build Vue.js app, and you'll see then it will move on to build Docker image, push to ECR, container scan, update service config, wait for the Davra service to run the new container, and then finally run the playwright and Tenable jobs. So in total, this pipeline will usually take maybe around 10 minutes, just under, and then on top of that, after, it will run the playwright and Tenable pipelines. The playwright will take about 3 or 4 minutes, and then Tenable takes closer to 10 minutes. So we'll pause the video here and we'll come back once the all 3 of our pipelines have finished running. So I will see you in a few minutes. Okay, so our pipeline has finished running. So now we can see, so clone repository, install dependencies, build Vue.js app, build Docker image, pushing to ERC container scan, update service config, wait for Davra service to run the new container, run playwright and Tenable jobs, and then playwright job and Tenable job. So in total, took about 20 minutes, or just under it, mainly because it was waiting for the playwright and Tenable jobs to finish. On its own, without the playwright and Tenable job, it would be about 8-9 minutes. So then if I go back just to show you, so here's the playwright job. Yeah, that took 3 minutes 39 seconds. And the Tenable, yeah, about 9 minutes. So there you go. And now if we go, so as I said, the image was going to be tagged with the build number. So if we go, build number is 5. And now if I go to my unit 8, I can see updated build number to Paul test 5, and it's now running. So you can see kind of running. And now if I click, I'll just open an incognito tab, so I'm prompted with a login. We can see, and we can see this is the member I added these images when I was configuring the OAuth client. So this will be the login screen for a user trying to log into our IoT application. Okay, so let's log in with the user we created earlier. So was it unit 8 user and password. And we can see this is our sample application. These are all the devices on my tenant. You can see a map with the devices that have GPS coordinates. If you go to graph, this is just random data. So yeah, you can explore this more yourself, or you can expand this app, add some new features and components. Entirely up to you. But as far as this tutorial goes, we have finished Unit 8. So thank you for watching.